Now, simple roots and surds. Dear students, you should recall that the square roots of 2, 3 and so on, written as under root 2, under root 3 and so on, cannot be exactly determined, and that the approximate value of under root 2 is 1.414 and that of under root 3 is 1.732. If any root of an arithmetical number cannot be exactly determined, then it is known as a surd. For example, under root 2, under root 3, under root 6, under root 5, cube root 4, 4 under root 5, and so on are all surds. A surd is an irrational number. If the root of a number can be exactly determined, then it no longer remains a surd. For example, under root 4 is equal to 2, under root 9 is equal to 3, cube root of 64 is equal to 4, and so on. Thus, numbers which are surds are irrational numbers, and those which are not surds are rational numbers. In algebra, an expression of the form under root x or under root a is called a surd. When x is 2, under root x is equal to under root 2, which is a surd. Similarly, if a is 3, under root a is written as under root 3 is a surd. But when x is 16, under root x equals to under root 16, which gives us 4 as the product, which is not a surd. Therefore, algebraic surds are determined if their numerical values are known. Now, simplification of surds. We start with the addition and subtraction of surds. Students, consider the surds under root 12 and under root 75. Here, under root 12 can be written as under root 4 into 3 or under root 4 into under root 3, which gives us 2 under root 3 as the answer. And again, under root 75 can be written as under root 25 into 3, which can be broken down as under root 25 into under root 3. This gives us 5 under root 3. These two surds contain the same under root 3, so they are called like surds. Thus, two or more surds which have the same irrational factor or surd are like surds. Like surds can be added or subtracted. Consider the two surds under root 8 and under root 80. Here, under root 8 is equal to under root 4 into 2. That is under root 4 into under root 2. This gives us 2 under root 2. And under root 80 as equal to under root 16 into 5. That gives us under root 16 into under root 5, which is equal to 4 under root 5. These two surds do not contain the same surd. These types of surds are called unlike surds. Students, unlike surds cannot be added or subtracted. Students, look at this example. It says simplify. Here we have to simplify the cube root 128 minus the cube root 54. Here, cube root 128 and cube root 54 are unlike surds, hence cannot be subtracted. So let us first change them into like surds. For this, let us factorize 128, which is equal to 4 into 4 into 4 into 2, and write cube root 128 as cube root 4 into 4 into 4 into 2. Students, also 54 can be factorized, which is equal to 3 into 3 into 3 into 2, and write cube root of 54 as cube root 3 into 3 into 3 into 2. Now, cube root 4 into 4 into 4 into 2 can be written as cube root 4 cube into 2, and cube root 3 into 3 into 3 into 2 as cube root 3 cube into 2. Students, in next step, using root law of indices, we can write it as 4 to the power 3 into 1 by 3 into cube root 2 minus 3 to the power 3 into 1 by 3 into 2 to the power 1 by 3. By simplification, we can write 4 cube root 2 minus 3 cube root 2. Here, 4 cube root 2 and 3 cube root 2 are like terms. Hence, we can perform subtraction. So, in the next step, taking cube root 2 common, we write cube root 2 4 minus 3 equals to cube root 2. Multiplication and division of surds. Students, the surds of the same order are called equiradical surds. For example, under root x, under root 3, under root a cube, under root x plus y whole cube are equiradical surds because they all have the same root symbol. A surd of the second order, such as under root 5, which can also be written as 5 to the power 1 by 2, is called a quadratic surd. a surd of the third order, such as cube root 5, which can also be written as 5 to the power 1 by 3, is called a cubic surd. We can easily multiply 2 or more equiradical surds. Similarly, we can easily divide a surd by another equiradical surd. For example, under root A into under root B is equal to under root AB. That is, under root 2 into under root 3 is equal to under root 2 into 3, which gives us under root 6. Similarly, cube root x into cube root y equals to cube root xy. That is, cube root of 5 into cube root 16 equals to cube root 80. Under root a divided by under root b is equal to under root a by b. Fifth root of x divided by fifth root of y square is equal to fifth root of x by y square. Similarly, fifth root 25 divided by fifth root 5 can be written as fifth root 25 by 5, which equals to fifth root 5. Now, the rationalization of surds. Students, we know that under root 2 into under root 2 is equal to under root 2 whole square. That gives us 2. Again, under root 5 into under root 5 is equal to under root 5 whole square, which gives us 5. Under root 7 into under root 7 equals to under root 7 whole square, that is equal to 7, and so on. Therefore, if we multiply a surd of the form under root x by under root x, we get the rational number x. Thus, to rationalize under root a, we have to multiply it by under root a. Students, again we know that a plus b, a minus b is equal to a square minus b square. So we can write under root 2 plus 1 under root 2 minus 1 is equal to under root 2 whole square minus 1 square, that equals to 2 minus 1 equals to 1. Similarly, under root 3 plus 1 under root 3 minus 1 equals to under root 3 whole square minus 1 square equals to 3 minus 1, that is 2, and so on. Thus, to rationalize under root 2 plus 1, we have to multiply it by under root 2 minus 1. The numbers under root 2 plus 1 and under root 2 minus 1 are said to be conjugate to each other. Similarly, to rationalize 2 under root 5 minus 3 under root 2, we have to multiply it by its conjugate 2 under root 5 plus 3 under root 2. Thus, 2 under root 5 minus 3 under root 2, 2 under root 5 plus 3 under root 2 is equal to 2 under root 5 whole square minus 3 under root 2 whole square, which gives us 4 into 5 minus 9 into 2, which is equal to 20 minus 18, that is 2, which is a rational number. Thus, as a rule we have, if a monomial surd such as under root x is multiplied by itself, we get a rational number, that is, under root x into under root x gives us x, which is a rational number. If a binomial surd of the form m under root x plus n under root y is multiplied by its conjugate m under root x minus n under root y, we get a rational number, that is m under root x plus n under root y, m under root x minus n under root y, which gives us m square x minus n square y. The product or quotient of two surds need not always be a rational number. For example, under root x into under root y is equal to under root xy, and under root x divided by under root y is equal to under root x by y, which yields surds as the product or quotient respectively. Students, now look at this problem. It says simplify under root a square plus x square plus under root a square minus x square by under root a square plus x square minus under root a square minus x square. Here, the conjugate of under root a square plus x square minus under root a square minus x square is under root a square plus x square plus under root a square minus x square. We multiply numerator and denominator by it to rationalize the denominator. Students, on multiplying the expressions of numerator, we get under root a square plus x square plus under root a square minus x square whole square, as a plus b, a minus b is equal to a square minus b square. Multiplying the expressions of denominator, we get under root a square plus x square whole square minus under root a square minus x square whole square, as a plus b whole square is equal to a square plus twice ab plus b square. In numerator, we have under root a square plus x square whole square plus twice under root a square plus x square under root a square minus x square plus under root a square minus x square whole square, as under root a square plus x square whole square is equal to a square plus x square, and under root a square minus x square whole square is equal to a square minus x square. So in denominator we have a square plus x square minus a square minus x square. On further simplification, the fraction can be written as a square plus x square plus twice under root a4 minus x4 plus a square minus x square by a square plus x square minus a square plus x square. This is equal to twice a square plus twice under root a to the power 4 minus x to the power 4 divided by 2x square. Taking 2 common in numerator, we have 2a square plus under root a to the power 4 minus x to the power 4 divided by 2x square. On further simplification, we get a square plus under root a to the power 4 minus x to the power 4 divided by x square.